mobile robots move, image processing, perception, path planning, learning new programming paradigms like functional programming, programming reconfigurable hardware like FPGAs through languages like Verilog and so on, right? All the things that you typically are not taught in your engineering colleges. One of the big problems in the country has been that our engineering colleges are not exposing our students enough to practical learning, which really disables you when you go out into industry to look for jobs. So the role of eYantra has been over the last decade to build infrastructure through eYantra labs. We built about 450 labs in colleges, and to seed an ecosystem, an innovation ecosystem, and to train you in these complex skills online at a distance, right? Which we've been doing for the past 10 years. And the outcomes of eYantra have been students have been getting placed very well. They've been going for higher degrees, masters in the top universities in well abroad and in India, and they're spontaneously doing startups, right? They're actually doing startups, and startups which are engineering startups, not the websites and apps, which are just doing data analysis and stuff like that. One student, for instance, has built a company called Catamaran in Coimbatore, which is doing mobile robots. And we've been buying robots from them also. And last I spoke to Muthu, who's our alumnus, he's been selling security robots to companies in Singapore. And the last I spoke to him, he was at a 7-star hotel in Singapore selling them delivery robots. So we have all sorts of cool startups which our students are building. And at the core of all these accomplishments of our students is the technical training that we are able to give them at a distance, right? So to give you a flavor of one such area that we train students in through the competition, through our hackathons, through our MOOCs and stuff like that, is today's introduction to image processing by my colleague Abhinav Sarkar, who came to us through the competition, through the internship. He became project staff at eYantra, and now he's registered to do a master's, an MTech in the Educational Technology Department of IIT Bombay. Right, so this will give you a flavor of the kind of things we train you in. We have two flagship competitions, incidentally. One is the eYantra robotics competition, which lasts 6 months. The registrations for that just closed on the 25th of August. And the other is the eYantra Innovation Challenge, in which we train you to do startups, right? So students find it very difficult to do startups because you don't know what to do a startup in. People have trained you to solve problems, but you don't know what problem to solve, which is what entrepreneurship is really all about. Entrepreneurship is about finding unmet needs and solving those problems. The bigger the unmet need, the more money you'll make. Okay, but we are not trained to think like that. So the whole effort of eYantra is to create this new kind of individual who will survive in the future job and opportunity marketplaces by making them more self-reliant, by making them, training them to be entrepreneurial in their thinking. It doesn't mean that you have to do a startup, but even if you are an employee in a company, you'll do far, far better than others who've not been trained in this kind of way. So without much ado, I'll hand the floor over to Abhinav. Abhinav, are you there?
Yes, I'm here. Am I audible?
Any any questions? If anybody asks, I am happy to answer them. Abhinav will be happy to answer them, or whoever. How many faculty do we have in today's meeting? If you can just raise your hands, please. Okay, 2, 3. Okay, a small number of faculty. I hope you find this session rewarding. So without much ado, I'll hand the floor over to Abhinav. Abhinav, over to you.
Hello. Yeah. So I'll just start sharing my screen. Just give me a minute. Uh, yeah, so good morning, everyone. So, my name is Abhinav, and I am a senior project technical assistant at e-Yantra IIT Bombay. So, I will be starting with this. I will be giving you guys a brief introduction of image processing using OpenCV, and so this is the title of the session. Before I move on to the contents, I want to know if somebody knows what exactly is image processing. So, have any idea? Please post in the chat that what exactly do you think is image processing? Where is it used? Why do we need to learn it? I just give you 2 minutes for this. Yeah. So somebody says that it's used for detecting objects, identification of objects, face recognition. Uh, Pictures can be made sharper using image processing. Somebody somebody also said GIS applications. I think there is some noise. I think somebody needs to.
You all are not speaking, then please mute yourselves. That'll be next.
Okay. So basically, you guys have given me some application of applications of image processing. So image processing is has a wide range of applications. Like if we have an image, we can perform all kinds of operations in order to extract information out of it and make sense of that information. That is what image processing or computer vision relates to. Okay, so let's move on to this. Let's move on to start this session. So first, I'll go with what this session is going to be about. Okay, so we will basically be getting you acquainted with some basic concepts related to image processing. So, since we will be using the OpenCV library, and so we'll start with basic image processing applications, basic image processing functions in the OpenCV library using Python, which are pretty useful. And we'll also discuss a few applications of image processing. So we have two demos that uh, I have prepared, and I'll be discussing those. What the session is not about. Okay, so I won't be going into the mathematics of image processing or computer vision. So if some of you must be knowing that image processing consists of a lot of math, and if you take any college level course on image processing, you'll see that there's a lot of mathematics involved. There is hardcore theory, theoretical mathematics involved. There's matrix multiplication and all kinds of transformations that will. So I will not be going into that. There will not. I will not be discussing machine learning or deep learning. So as somebody said that there are applications related to object detection or maybe face recognition. So these are some of these applications consist of machine learning or deep learning, which I won't be discussing because that is not in the scope of the session. And so this session is going to be very basic about how to get started with OpenCV. So for prerequisites for the session, so one prerequisite is that you need to get familiar with the Python
तो वो टेक्स्ट
library.
कौन कौन बैठता है? सब इकट्ठा बैठते हैं, सब इकट्ठा बैठते हैं।
You need to be familiar with the Python library and Python language and the numerical Python library. And the other thing is that if you want to follow along while I'm working on it, you need to have installed all the required software for the session. That is Python and the respective libraries that are related to Python. Okay, so and since I won't be going into a hardcore mathematics, but yeah, you still need a little bit of understanding of mathematics in order to understand what is going on. Okay. So let's get on with the agenda. So firstly, I'll be going into the basics. What is image processing and computer vision? How to get started with it, and then I will be discussing two demos. One is object detection, and the second is building an invisibility cloak. Okay, so let's firstly, let's discuss what exactly is an image. Okay, so I'll take the example of a human eye. We'll start with the human eye. Basically, that's so. If we talk about the human eye has this lens called has this. If you look at all the parts of the human eye, we have this lens that is basically taking in the light from the outside, and there's also one screen which is called the retina. And the human eye basically does is that it basically what the human eye does is that it takes in light from the outside, and the image is projected onto our retina, which is then processed by our by the by the cells on our eye and processed by the brain. So the image is basically formed on our retina, and then it is processed by the brain in order to extract information. Similarly, we can, on the same analogy, we can talk about cameras. Okay, so cameras are nothing but very similar versions of an eye. So let's say we have in a camera there is a basic there is a film or a screen on which the image that is being captured is basically projected, and there's a lens which captures light from the outside. So whatever the lens is seeing from outside, it gets captured into the film. Okay, so here I'm talking about the older cameras, the Kodak cameras. I'm not sure how many of you are familiar with those. Similarly, there are digital images or modern digital we have modern digital cameras as well. So these are different because in addition to the lens and the screen, there's also other processing involved. So what is happening in modern digital cameras is that it is all the information that is captured from the outside, it is digitizing that information and then storing it into a memory. Okay, so there's an image sensor which is capturing the information that is captured from the outside, and then it is processing that information into some particular format which a computer can understand. Okay, so the computer is a very stupid system. It does not understand everything, like it does for example. Okay, so the image processing engine converts that information into something that a computer can understand, and then it records it into any into any memory, whatever memory the computer has. Okay. So how is so when we talk about what kind of information is the computer like, what is when we talk about an image, what is it that, what exactly do we mean by an image? So in a very basic thing, an image is nothing but a matrix. Okay, so let's talk about here. So if we talk about this small image, and so it's nothing but a bunch of cells, and each cell has a particular gray value. Okay, and that gray value has a number associated with it. For example, let's say that this is our grayscale spectrum. So this spectrum is continuous. Okay, that is that there might be infinite shades of gray that might be present here, from pure white to pure white. There, in a continuous grayscale spectrum, there are infinite shades of gray. However, in case of a computer won't understand infinite. It won't have the space to store this infinite shades of gray. So it quantizes, or it divides this into levels. Okay. So what happens is that it divides it into 256 levels. So 0 represents pure black, and 255 represents pure white. And all the levels in between, all the different, there are 254 shades of gray between pure black and pure white. Those are represented by 1 to 254. So it's basically that grayscale spectrum was digitized. It was quantized into levels, so that every level is represented by one particular number. And you'll see that in this image, that is what is happening here. So 170 represents this particular shade of gray. Then 238 is represented by this shade, and so on. So it's nothing. So an image is nothing but just a matrix with some values in it, some numbers in it. And these numbers, in order to extract information, we just need to understand what these numbers mean. So similarly, so here, next we move on to pixels. Okay, so pixel is basically the smallest unit of an image. So for example, we have an image that is, as I said, that image is a matrix. It might be m columns and n rows. So the pixel is the smallest cell that is there. And for a grayscale image, each pixel would have a value between 0 to 255. Okay, that is represented by 8 bits in binary. So can somebody tell me why it is 0 to 255? Why not some other range? Yeah, so some of the people have said that it's, since it's 8-bit, so 8-bit means that the range, since it's a 8-bit image, that means that the numbers should be between 0 to 2 to the power 8. Okay, so that is 256. In case it was a 10-bit image, then the image then the number range would be 0 to 1023. Okay. I was seeing that there were some issues with the with the sound. Is the audio clear right now? Should I make some changes? So similarly, RGB images are represented by just give me a second. I'll try and see if I can change the. So is this clear? Is this better? Okay, fine. Yeah, so I have another request. Please, everyone who please turn off your microphones because there's some background noise that is coming. So I hope that there are no questions till here. If there are any questions, please ask them on the chat. Okay, so moving on. So as I said, RGB images are represented by M cross N cross 3. So how is M? What do you mean? What do we mean by M cross N cross 3? That is that any image, any colored image, and for any colored image, you can divide it. You can basically divide it into 3 channels. So there are 3 channels: red, green, blue. So any color, if you have a, if you think about it, any color that you see in the visible spectrum, it is just a combination of red. It can be created with the combination of R, G, and B of different intensities. Okay, so that is why any colored image is represented as a matrix, as a 3-dimensional matrix, that is M cross N cross 3. Okay, that means that M represents the number of columns, N represents the number of rows, that is same as a grayscale image, and 3 represents the number of channels. Okay, so one channel is for red, one channel is for green, and one channel is for blue. So we'll come to that, how that gets actually gets represented in OpenCV. So yeah, I think Jignesh has asked that why is 0 assigned to grayscale? So the idea here, it's a convention that we that is universally followed. So 0 is basically total darkness, and 255 represents total brightness. So everything in between is different ranges of brightness. Okay, so that is why for grayscale 0 represents black. Yeah, so in so as I said, in RGB images, 3D it is represented as three matrices. So any image that we have, it can be represented into three channels: a red channel, a green, and a blue. And the combination of these three channels give us the final image. So I have a question for you guys. Okay, yeah, sorry, I actually just paused. So what is the size of a grayscale image with dimensions 32 cross 32 pixels? So I gave the solution accidentally. So I'll pose a new question to you. So what will be the size of a grayscale image with which has dimensions 64 cross 64 pixels? Yeah, so the answer you are saying is correct. It is 4 kilobytes. Okay. So I'll pose a harder question for you. What happens if it, instead of a grayscale image, it is actually a RGB image of 64 cross 64 pixels? Yeah. So so you guys have the right answer. 64 for, so for calculating the size of a normal image, we just, so 32 cross 32 into 1 byte is 1024 bytes. In case of a RGB image, it is multiplied by 3 bytes because there are 3 channels. Okay. So let's move on to the theoretical difference between image processing and computer vision. So here there is a small confusion, because usually what happens is image processing and computer vision, these terms are used interchangeably interchangeably. That is that somebody would say computer vision, but they might mean image processing or something like that. So computer vision is actually a broader area that encompasses a lot of different areas. So we can say that computer vision image processing is just a small subset of computer vision. Computer vision in general refers to high level understanding. That is, how do I make sense of an image? Like, for example, if I have an image in which one boy is sitting, so that high level understanding is uh, if we talk about that high level of understanding that in this image one boy is sitting, that is computer vision. Image processing is low level detection, that detecting shapes, detecting lines, detecting edges or corners, or removing noise. So some of the lower level operations that we need in order to make an image more understandable, that is image processing. So yeah, so let's move on to the programming part of this session. So I'm hoping that you guys have held on till now, and so we'll stop this and we'll move on to the programming part of the session. Okay. So the theory was basically just a precursor, that if you guys don't have any idea about OpenCV, then this is just a basic. Okay. Fine. So is this screen visible? Okay, fine. So let's talk about, uh, let's start from the top. First, we'll be discussing some basic operations that are related to image processing. Okay. So for image processing, we have one of the main functions that you need to know before you start with image processing are these three main functions: loading an image, displaying an image, and writing an image. Okay, so first we'll move with loading an image. So you'll see that this is just basic Python syntax. I'm importing two libraries, NumPy and OpenCV. Okay. So first of all, let's see how this to image read function works. So this is basically for reading or loading an image. There is. Yeah. So you'll see that we have this image, and this image file is OpenCV underscore logo.png, and we have given two print statements. That is the type of that image, that is what kind of data type this variable image is, and that what is the value in that image. So you'll see that this is a matrix. As I discussed earlier, images are nothing but matrices. Okay. And the type of that image is a NumPy array. So this is important because when we are dealing with images in OpenCV, so OpenCV deals with images in using NumPy arrays or n-dimensional arrays. Okay. So if you have any experience with the NumPy library, the numerical Python library, it's basically used for computations. So if I want to multiply two matrices, it's NumPy makes it very simple by providing a ready-made function, and I don't have to write it myself. Okay, so moving on, the second thing is displaying an image. So for displaying an image, I'll use this function called imShow. So there are two parameters that I need to give in this imShow. That is, first is the window name, and the second is the actual image variable that is in which the image is getting stored. Okay. So for example, my image is getting stored in this variable image. So I'll specify that. The next two variables are wait key and destroy all windows. So these are basically required for generating and destroying that particular window in that is used for. So I'll try running this piece of code and show you. It's not quite working. Yeah. So is this window visible to you? Yeah. So you'll see that the first parameter image that I specified, that is the name of this window. Okay. And the second parameter is the image that I have loaded. into the memory. Okay. And this wait key is what it is doing is if I specify 0, then it will then this window will hold on until I shut it down. But if I specify a certain number, so earlier it was 2000. So 2000 is 2000 milliseconds. That is 2 seconds. So if I specify that particular number, then it will shut down after 2 seconds. So moving on, checking the dimensions of an image. So the next thing is that we need to check what are the dimensions. So for that, we use this function, use this property called shape. That is the property of any NumPy array. It's not just for image processing. It can be used for other matrix operations as well. Seems to be some issue with the yeah. So you'll see that this image, it has these particular dimensions. That is 243. That is the number. That is the number of columns. 207 is the number of rows. That is the width, and the 3 is the number of channels. So as I said, that RGB images are represented as M cross N cross 3 matrices. Okay. So there's another way to load an image, that is in grayscale. Okay. So if I use cv2.im read in grayscale, if I use a grayscale image, then if I just have to specify this particular parameter called the second parameter 0. That means that the image would be represented in a grayscale mode. Okay. So you'll see that my image has been generated in grayscale instead of the colored image. So this is visible, right, to everyone? Okay. Yeah, and you'll see that the image dimensions are also different. Earlier it was 243, 207, 3. Here it is 243, 207, since grayscale only has one channel. The last thing is saving an image. That is writing an image to memory. So you'll see that I have actually saved this image here. Okay. So when I call this function cv2.imWrite, you'll see that first I have to specify the file name of that image, and the second parameter is the image matrix that I have got. So image gray is the matrix that I have got here, and cv2.imWrite, it is the so in the second parameter I specify here. Okay. So you'll see that I have that image was saved here. Okay. So any questions till here? If you have any questions, please ask right now. Yeah, difference between saving and loading an image. So loading, what I mean by loading is getting it from memory. So I already have this image in my memory. I already have this image in my memory, and CV2 IM read is loading this into the OpenCV program that I'm using. And saving is the opposite. That is that let's say I have loaded an image, I have made some changes to that image, and I want to save those changes. So it's like opening a document and then saving it after you have made changes. That is the difference between saving and loading. Anything else? I don't exactly understand. So somebody said RGB channels. If an image has grayscale as well as color, will RGB make grayscale shades? So yeah, I'll come. So I'll come to that in a bit. So that is actually getting. We'll discuss later. Okay. Which software is used? So this particular software that I'm using, this is Jupyter Notebook. It's used for running Python programs. Anyway, like overall, we are using the Python language and OpenCV. Anything else? Is it possible with satellite images? Yes, it is. It is possible with satellite images as well. Like any kind of image, we can use image processing. It just has to be in a particular format. Okay. So let's move on. Let's move on. Okay. So here, let's talk about accessing the individual pixels. Okay. So as I said that any image is just a series, is a matrix of pixels, and we can actually check the value of these individual pixels by, since this is a matrix, I can check the value of this individual pixel by specifying the index of that pixel. For example, yeah, Jignesh, I think that you are asking the questions on private. If you can click on everyone so that everyone can see what questions you are asking. Okay. So pixel, so for example, here what we have done is that I want to check the value of this gray pixel. So I want to specify that at 120, 120, what is this value? Okay. Similarly, I want to check the value of the pixel at for the RGB image. I want to check the value of this pixel. So there's a key difference here. Here I am specifying the exact indexing. So 120, 120, I want to check the value of that individual pixel. For the RGB image, I am checking, I want to check all the three channels. Okay, so for this particular thing, I want to, the M cross N is 120, 120, but this thing means that I want to check for all the three channels, for the red, blue, and green. Okay, so let's see what. There is some issue with this.
Actually, there's some seems to be some issue with this function. I think we need to restart the kernel because there seems to be some issue with the IAMWrite function. Let's delete this. Yeah, so I think I'll move on to the next part. That is the region of interest. So I think there is some issue with this particular image. So I'll this particular notebook that I did not realize earlier. So we'll have to see. So just yeah, just give me a moment, please. I need to. There seems to be some issue with this. So is this visible? So I'll answer the questions once I get done with this part. Yeah. So accessing the individual pixels, as I was talking. So we specified this particular value. So you see that the pixel color or the pixel value at that particular pixel index is 29. That is the value that is at that particular pixel. For the second thing is the for the RGB image, that image is 255. That value is 255, 1, 1. So let's see this image first. Okay. So 120, 120 would be somewhere here. 120, 120 would be somewhere in this area. Okay. So that means that the value of in grayscale mode would be this particular value, 29. Okay, let's see, open that. So 29, you'll see that this is a darker shade of, this is almost black, but not exactly. It's slightly dark. Okay. And in this, the RGB pixel color, it is 255. 255 represents blue, and this represents 1 and 1. So this is basically that since it is somewhere in here, that means the blue component of that pixel is more and the red and green components are less. That is why the value is like this, 255, 1, 1. Okay. Let's try changing that particular pixel. So you'll see that when I tried changing that pixel, is this window is visible, I hope. Yeah. So you'll see that there's this small dot that that is there in this. So that is the change that I made to that individual pixel at 120, 120. Okay. So what I did here was I just gave this individual pixel a value of 255, 255, 255. That is white. So you'll see that there's this small white dot in the center of this here. Okay. So this is one of the ways where yeah, Jignesh was asking that 1, 1 in RGB, what does that denote? So 1 means that there is that. So here 255 means that the blue component is more, and the 1 and 1 denotes that there is no red, there is very less red and green component. So every every color is a product of 3 components. So in some color the red component would be more, the blue and green components would be less. In some colors the opposite would be true, and some colors would be the mix of all three. 255 255 255, that is pure white, is basically in which all the components are full brightness. So every color is actually a combination of these three red, blue and green components. So next I'll move on to accessing a region of interest. That is, let's say that I have some image and I want to access one small portion of that image. So that is so in order to do that, I use this command called region of I use simple array matrix. So you'll see that here what I did was that I specified a window 0 to 255, 0 to 25, 0 to 25, and the 3 channels. So you'll see, and I set all those pixels to 0, 0, 0. That is pure black. You'll see that I have this small black square in the top left corner. So so that means that I can basically access all the 3 channels. I can access multiple pixels at one time. Okay. So let's say that I want to crop an image. So it is possible to do that as well. I just have to use this particular, I just have to take up a small part of that image. So let's try doing that once. So you'll see that here the image cropped. What I did was that I specified the dimensions. So I specified that 0,205, 0,205 and 3. So this is the area that I required. So you'll see that this image is small, actually smaller than the earlier image. So the dimensions are 205, 205. That is different from the actual image that was 243, 217 or something. Okay. So last, I'll move on to the individual channel, checking out the individual channels of an RGB image. So as I was talking about is an RGB image consists of 3 channels. And all these 3 channels have different values. Okay. So you'll see, so let's see this. So here what I have done is I am specifying these individuals. So 0 stands for the blue channel, green channel is 1 and the red channel is 2. Okay. So just refer to these individual images once. So in the blue channel, this is the blue channel, you will see that this particular the OpenCV, this particular area is not visible because the blue component is full 255. Okay, these components are visible because these are effectively 0 or 1. Okay, so in a grayscale image, it will look as pure black. Similarly, in the green channel, you'll see that this particular belt is missing, and in the red channel, you'll see that this one is missing. If it was some other color, then I would see a combination of these, and I'll see some shades of gray here. I think there are still some doubts related to how these individual channels work. What does the channel, what does 0, 1 and 2 mean? So 0 means the 0 basically is this is array indexing. Okay, so there are 3 channels, so every channel is given every channel is given one particular index. So by default in OpenCV, the blue channel is given the index of 0, the green channel is given the index of 1, and the R channel is given the index of 2. Okay. So Jignesh, in case of 3 channel RGB, if it is 1, 1, 1, that denotes that there is then that would denote a pure black image. So for example, if I take this image, if I compare it with this, okay, let's just compare it with this image. Okay, so this part is pure black, almost pure black. So here the value of all 3 channels would be say almost 0 or close to 0. Okay, but here in this area, the value of the blue channel will be close to maximum, that is 255, but the other channels would be close to 0. Okay, that we saw earlier. Similarly, here the red channel would have the maximum value, but the other 2 channels will have 0 values. Why is- Okay. So that is how images are formed. These are basically combination of these 3 channels, the colors of these uh, 3. So RGB if R at max will be 255. Yeah. So if the red, so in this case, the red is visible. That means the R would be 255. The other 2 colors would be 0 or 1. Okay. So I think we spent a lot of time on this particular, and So we'll need to go a bit quicker in the next 2 sections. So the next part is some basic image processing functions, that is the resizing and rotating an image. Okay. So what does resizing mean? That is that if I want to change the dimensions of any image, I can do that using the OpenCV, using some functions in OpenCV that are used for resizing. So let us say that I have this particular image with me. Yeah. So you'll see that this is this visible to everybody? Yeah, so this is a very big image. This is, as you can see, this is does not even cover my whole screen. This does not even cover my whole screen. That is because okay. So you'll see that the image dimensions are very large, 2624 1920. Okay. So what happens if I want to resize this image? Okay, so let us say that I want to resize the width of that image. I can use this particular function called cv2.resize, and using this function, uh, I can resize. So let us say I specify the width as 500, and after that I call this function. So I am specifying that particular image. I'm specifying the width and the height. The height is same as earlier, that is 1920. And the interpolation is basically how there are certain modes in which I can resize. So I'll leave this to you in order to Google what is interpolation, because it is not easily explainable in 1 or 2 lines. Okay, so there's a detailed definition in the OpenCV documentation for this. So let's see. So I changed the width of this image to 500 pixels. Okay, so you see that this image here, the width is changed, but the height is same. That is, it is same as earlier, 1920. But obviously, since only we changed the width, this looks very wrong. So let's try changing the height as well. Let's change the height to 500 as well. Okay, so now width and height both are 500. So here I have changed both the width and height. It is still, so this image is now 500, 500. This still looks a bit wrong because we are not preserving the aspect ratio. With this particular image has a particular aspect ratio. So aspect ratio is the ratio between the width and the height. So any image, so in this case, that ratio would be 2624 divided by 1920. That would be the aspect ratio of this image. So I'm not preserving the aspect ratio here. That is why this image looks very weird. So how do I preserve the aspect ratio here? That is by calculating calculating the width and height proportionally. So let us say that I want to let us say that I want to scale this image by 0.3, by a factor of 0.3. What I would do is I would multiply the width and the height by the scale factor 0.3. Okay, so the width and the height would so the width and the height, the values of the width and height would be such that the aspect ratio is maintained. If I do this, then I get this. So you'll see that the image gets smaller, and I am also preserving the aspect ratio of this image. So this is so here this is nothing but basic mathematics. Like I specified a scale factor and I just multiplied the width, the actual width and height by that particular scale factor. So is this clear? Uh, uh, yeah. So this is actually a good question. It's this dash. Okay. So image dot shape. So when I'm checking the property, so this should so earlier if you we discussed this image dot shape, this actually returns three values: width, this is the width, this is the height, this is the number of channels, correct? Okay, but I don't, but here I only want to worry about the height and width. Okay, I don't want to deal with the number of channels. Okay, so I can just say that instead of I don't need the number of channels. Okay, I'm not using that value. So I can just specify this dash. This dash means that I don't want to use that value. I could replace this with channels, like another variable called channels. I could do that. But the point is that I'm not using this. If I was using that particular variable, then I would require that. So this is usually in Python, this is usually something that we do we sometimes uh, omit some variables that are being returned by a function. So I won't go into the rotation of an image because that is not very relevant to the next section. So I'm omitting and we are a little bit short on time. So next, let's move on to the drawing functions. Okay. So there is so in OpenCV there is another range of functions that we use that are specifically used for drawing something. Let us say that we need to annotate an image. We need to add some information to an image. Okay, like let's say there's an object. We need to label that object, or we need to draw some lines around that object. Okay. So for that particular reason, we use something called drawing functions. So I'll go into drawing functions one by one. So first, let's think about creating a blank canvas. So this is our blank canvas that we have created. So how did I do this? This is a blank image. This is I created a numpy array which is all zeros. Okay. So 500, 500, 3. This whole numpy array is populated with zeros. That means that all the values are zero. That is why this full image is black. And np.uint8. What does this mean? Can somebody say, tell me? Yeah. So as Rohan said, this specifies that this is going to be an 8-bit image. Okay. So every value is going to be 8-bit here. So let's try drawing a line here. So I have to specify. So for drawing a line, there I have a function called CV2 line. So here what I did was that I specified point 1, that is 499. That is, I specified two coordinates. That is the start of that line and the end of that line. I also specified this color of the line. So 0, 255, 255. This specifies yellow. And the thickness of this line is 3. Okay. So this what this does is that this so CV2 line function, what this is taking these these parameters as input. So you'll see that canvas is the first parameter, that is our blank canvas that we created. Then point 1, point 2, then the color, and then the thickness. Okay. Similarly, CV2.rectangle. So here point 1 and point 2 have different meanings. For the CV2 rectangle function, it means the top left corner and the bottom right corner. So this is 200, 200. This is 300, 300. And what we do is that we call the CV2.rectangle function in order to draw this. So this is pretty straightforward. We just have to specify the points and the color and thickness. So here I have drawn a green rectangle. Similarly for circle as well. So the point here is the center of the circle where I want my circle to be present. The radius is what is the radius supposed to be. So I have specified the radius as 70. The color is what I want my color to be. And the thickness is as I said. So CV2 color is specify the point, radius, color, and thickness. Okay. So let's try to do something fun here. So I have created this small piece of code. So can you guys guess what would be the output of this? There's a clear hint in the image in the code itself. Let's try running this. So here I am using all those all the functions that I used earlier. So for CV2 circle is for drawing this particular circle. Then canvas, then CV2 line is for drawing this this triangle. So I have specified these 3 corners here, and using these corners I am drawing the triangle. And another CV2 line is for drawing that vertical line. The next, and how I write this is I use this function called cv2.putText. So as I said that maybe we want to annotate some object or something in the image. So for that, I just need to specify the text along with the font and other parameters. So I want to specify what would be the font here, then the color, the scale, the thickness, and all those parameters. Yeah, so I hope this was this this was understood by everyone. So any problems till now? Any issues? So if you have any questions, please ask on the chat. How to make moving lines. So what do you mean by moving lines? Do you mean like to animate? Okay, so for animation, there's a different there are different ways to animate. So for moving lines, actually, so if you know, if you think about animation, it's just a set of frames that is being run very fast. Okay, so let's say that line would be at one position at in one frame, and then in another position at another frame. So that is how videos work. Videos or animations work. So it is possible to animate as well using OpenCV, but that is still a bit that is still a bit more complex. It's basically you create a set of frames and then change the position of these objects according to the frame. Okay, so Jignesh is asking which fonts are available in our library which we can use. So yeah, this is the most basic font that is available. But I think that you can check in the OpenCV documentation that what other fonts, and also it is possible to load fonts as well. So I'm not sure of the process because I haven't done it. Is there a way to delay the printing of a line after the output is shown? So it is possible. It is just that you'll have to do it stepwise. So let's say that I try this. Okay. So here the program is stopped until I push a key. So once I push my key, then it all appears because this program gets stopped here. Yeah. So I can do this. I can do this in multiple ways. Let's say that I place it here, then here. Okay. So if I keep pressing my key here, this stuff will start appearing. So that's how I can. So this is actually creating multiple frames. So every time I'm making a change to this canvas, I'm displaying it. So that's how I can delay it. I can also change this value to some actual 2 second or 4 second or something so that it actually so I don't have to keep pressing my key. That can also be done. So I guess we can move on to the next part. So this was just a basic idea of OpenCV. So I think we can we'll move on to the. So I did not end up using this slide. That is object detection. So this is where we actually end up using we end up using. So what I showed you till now, these are just some basic operations that I can do in image. Okay, so you must be wondering how do I use this practically? So there are multiple ways to use this practically. So let's say that I want to do something like an object detection. So object detection is also multiple times. I'll just be showing you the very basic, the simplest of that. That is object detection using color. So yeah, is my camera visible? My camera on? No. Yeah. So I have this Rubik's cube here. You will see that this Rubik's cube has different faces, and each of these different faces has a different color. So we'll try detecting this particular Rubik's cube. We'll try to track this Rubik's cube in using OpenCV. Okay. So let's try doing this. So now I'm moving from Jupyter, since I'm moving to a normal coding environment. So this is the program that I have created for normal image object detection, and I'll go into this line by line. Okay. So firstly, let's look about let's go from the first line itself. So see, this is video capture. So in order to detect any image, let's say that I have my webcam set up and I want to detect this particular image. Okay. So what do I do to detect this image? Let me just run this code. Yeah. So is this visible? Uh, So you'll see that this frame is this frame you are seeing a orange kind of frame, that is actually an anomaly because the wrong camera is selected. So I'll select the correct camera here. Yeah. So this frame should be visible to you. So you'll see that my image is getting displayed in the OpenCV frame. Okay. So I'll go line by line. As somebody asked, what is this part? If name main. Okay. So this particular, if you are familiar with Python, so Python, what happens with Python is that if I want to import this particular, let's say that I am this is the main. This specifies the main part of the code. So this is where the execution will happen. Okay. That is that all this code that I have written here, this gets executed. So this is just a play. This is slightly unnecessary here, but this is basically that this specifies that this is the main part of the code where the execution happens. So there are other implications of that, but I'm not going to go into detail because that's more on the Python end. So let's go line by line. Firstly, we have to create a video capture object. Okay. So let's say that so in order to so here what I'm doing is that I'm capturing the video that is being streamed to my camera. So for that, I have to create a video capture object and I have to specify the camera number. So in OpenCV, there are like in your computer, there might be multiple cameras. There is one webcam which is connected to your computer. There are other cameras also. So in my case, I have created an external, I have connected an external webcam. Okay. So initially that orange screen that you saw, that was because another camera was selected by mistake. So that at that time it was here it was written 1 instead of 0. So 0 means the default webcam of the computer. So you can toggle this by changing this value. So here 0 means that I have selected this the particular webcam that I've connected. The webcam that I've connected. Okay. So the next thing is vid.read. So this is basically reading the frame of the webcam. So you'll see that what I have done is that I have put this inside a while loop, in an infinite while loop. So I hope you guys know what this statement means. While true. The statement means that this particular piece of whatever I'm writing inside this while loop, this will keep on repeating infinitely. Okay. So what it's happening is that every time, so it is keeping on retrieving that frame. So this is the frame that I'm retrieving. That is the frame variable, and this is the return code. That is whether the frame was successfully returned or not. Okay, and I'm retrieving that frame, and then I'm showing that frame. So this window that is visible, that is because I'm calling that IMShow variable. After that, I am calling this particular piece of function, this particular piece of code. What it does is that it holds that frame for 1 millisecond. So as I showed earlier, the wait key function, it will hold that particular window for a particular amount of milliseconds. So if it was if it was something like 2000 milliseconds, then every frame would hold for 2 seconds. Yeah. So in that case, there would obviously be some latency in our code, but we don't want that. So right now you'll see that there's no latency in that in this video. It gets updated as I'm moving. That is because the wait key variable is set at 1 millisecond. So that frame gets refreshed every millisecond. So is that clear? Yeah, that's a good question. What is 0x FF odd Q? So that is actually used for breaking out of this infinite while loop. So if I press this Q button, if I press the Q button on my keyboard, then the video gets closed, because then then this condition is met and this breaks out of this while loop. So this is for exiting that infinite while loop that I created. I don't want it to go on and on. So I specified an exit condition. Is that clear? Fine. So let's move to line by line. So this is the basic code that is there just to display what is being captured by my camera. Now go line by line. First is convert this frame to HSV. And what is HSV now? So we'll go to that. So in OpenCV, what happens is that there are different kind of color spaces. So this might be a slightly on the harder side, and I don't expect you to understand it fully. But the idea is that RGB, red, green, blue, this is one kind of a color space. Okay. So I think some of you have got a flex printed, तो फ्लेक्स प्रिंटिंग वाला पूछता है कि वो किस में प्रिंट कराना है, CMYK में प्रिंट कराना है या किसी और में RGB में कराना है. वो मतलब there are different modes of so a color space is basically the way of addressing a color. So RGB is one way of addressing every color. So let's say this is the whole visible color spectrum that we have. So red is along one axis, blue is along one axis, and green is along one axis. Okay. Is this is so that is how the red RGB color spectrum works. Similarly, there is another kind of color spectrum called hue saturation value. That is slightly different. That is basically here there are different hues. There is a value and a saturation. So value and saturation is referred to the brightness of that. So you'll see that this is a conical or a cylindrical kind of a color space. That is that the hue is based on the on an angle, a 0 to 1, let's say 0. So hue is on this end. So what so I won't go into the, since I said that I'm not going into the mathematics or the theory part of this, but I'll just say that hue saturation value, this particular color space is more preferred over RGB. There is one very particular reason. That is that HSV is less sensitive to noise or lighting. Okay. Why is that? That is because in RGB, two shades of gray might have entirely different values. But the same would not be true for an in the HSV color space. So you'll see that all the shades of red, this might fall in this range. This will fall in this range itself. Okay. So it is much easy. So how do I detect objects? Let's say that I have this particular cube, this particular Rubik's cube, and I have this face that I want to detect. I want to detect this orange face. Okay. So what I'll do is that I'll set that I'll write a algorithm in such a way that only only pixels which have this particular orange color, only those pixels will be filtered out. Okay. So that way I'll specify that, yeah, this orange cube is in this location with this particular pixels. But it is very dependent on lighting. So let us say that I face it a little bit here. So you'll see that this is getting illuminated by lighting. So these values will change. The values in this frame would change, of this particular area would change. Okay, if I move it a little bit here, so these values will change. So what I need to do is I need to specify a range. I need to specify a particular range in which if it is detected, then then I can say that it is orange color. Is that clear, or Should I explain a bit more?
पगला है क्या को खवाना तो मैं चलता हूँ नहीं तो पेट लंच चाहिए
Ashutosh, please mute yourself.
If you are not speaking or asking doubts, please mute yourself.
So is this clear? Yeah. So this is so basic. As I said, the basic thing is that you need to set a threshold, a set of ranges that if the pixel values fall between this range, then this will. So you'll see that these RGB values. If I am here, so these RGB values are some particular values. It is also getting shown here in below. Yeah, so that how much gap that needs to be specified by us. So I'll show you how we do that as well. So let's so as I said that this threshold that we need to send, this range that we need to set, these ranges. So why we use HSV is that these ranges are much easier to set in the HSV color space. So what we do whenever we are using color-based filtering, the first thing that we do is that we change the color space from the BGR to an HSV color space using this function CVT color. This can be used to convert it into some other color space as well. Let's say that I can convert this into gray in a gray image as well. Let's try. Let's say I try doing that. Yeah. So you can see that this is my gray image and this is my actual. So it's basic. So what you need to understand is that these are just different color spaces that I am changing my image to. So that look, if I talk about the HSV color space, it would look something like this. Yeah, so this looks very weird. The second thing is setting these thresholds. So these are some specific, very specific thresholds that I have set. So I'll talk about why I'm setting this particular threshold. So for that, we'll run another program called Color Master. So this is the image. This is an image of the Rubik's Cube that I have captured. Now what I want to do is that I want to isolate just this orange color, as I said earlier. And I want to select the thresholds for this orange color. Correct? So what I can do is that I can try varying these values a bit. So what I want to do is that I want to highlight this. Okay. So as you can see that this is kind of what I want. So what I'm doing is that I'm varying these values in a certain way so that a mask is created. Mask basically means that I'm just isolating that particular image area that I want, and I'm specifying the color for that. I'm specifying. So you'll see that this value is 0. The hue value is 0 to 40. The saturation value is 80 to 55, and the normal value is 60 to 255. Even though this does not have a very detailed effect. Okay, so this can be 0 to 255 as well. So these are the thresholds that I have set here. So here the thresholds are 0 to 40, 85 to 255, and 176 to 255. These are the thresholds that I have pre-decided. So as you said, how much per plus minus, how much gap that we need to give, that depends on the color that we are trying to detect here. So in case of this I want to detect this particular image. So here I have these values that I need to, this is the range that I need to specify in order to capture just this and ignore everything in the background. Okay. So let's try running this code once again, and I'll show you the mask this time. Did not save that image. This is my original image. Let's see. You can see that this so here what I'm seeing is that this image, only this orange color is getting isolated, and even though there is slight bit of lighting, there is a slight effect of lighting, but it's still a pretty good threshold that I have set here. Okay, so this is how I'm isolating that image. That particular color, this is how I'm isolating that this particular orange color. If I turn it to yellow, then yellow would slightly be detected because it's closer to orange. But if I turn it to green, you can see green is not getting detected. So moving on. Now the next thing is removing noise. Even though this is this particular part is not very noisy, but there are there are some functions that we use for removing noise in a removing some basic noise in a image. So that is, there are two type of functions, that are dilation and erosion. Erosion is erosion that we are using here. What it does is it decreases the boundary of these white areas. So it might be that there would be some white dots here and there that might be appearing. So in order to or some noise, white noise that is appearing in that image and in that masked image. So in order to remove that, we will use the erosion. So if I use this function, if I call this cv2.erode function, that will reduce the noise substantially. You'll see that this is much lesser than what it was. I think I'm not sure how clear the video is, but this reduces all the noise in that image. There was some noise that was visible earlier, so it reduces that substantially. So next part that we are moving. So this is the main that we want to talk about. That is finding the contours. So what exactly is a contour? Now, the contour is basic idea is that the contour is a boundary of an area. Yeah, so some of you are asking, how do we open the window for setting the threshold values? So for threshold values, actually, so I'll be sharing this code with you uh, with you up with you later. So for setting the thresholds, it is actually a separate Python code that I have written. So that gives you the window and the track bar thing that we use for setting the threshold values. So that I will be sharing this part later. So in this particular one, we don't have that track bar part. So as I was saying, contour detection, contours are basically boundaries. So in any object that we detect, what we want is we want to detect the boundary that is encompassing that. So you can see in these cards that we have. You can see that this
scholarship amount lama kattuvaanga adu irukku therla.
you can see these cards that we have. The contours are like these closed curves are encompassed. Okay. So how do we detect contours now? So for detecting the contours, we have this function called contour hierarchy. So we can try drawing this. Yeah. So is this visible? You can see that this that are color that this face of this cube, this is getting surrounded by a red boundary. That is the contour that is being detected. So this This actually is the area, this boundary that is getting detected in this, that I'm displaying here. Okay. So this is how basic object tracking works. So as you can see that this boundary follows my object wherever. I can also try finding out some specific information about this boundary. Let us say that I want to find out where this face, what is the centroid of this face. So I can try finding that out. Or I can find out some other information. So let's try finding out the centroid. Or I can also try finding out the area of this. So I won't go into the area because it's slightly more, it needs a bit more explanation. So is this visible? So as you can see that I am detecting the center or the centroid of this Rubik's cube face that is getting detected here, and I'm just displaying that using the drawing function that I showed earlier. So how is it getting calculated here? So first, the thing is that we need to find the contours in this function. So that is done using the CV2 find contours function. Okay. So we specify the masked image, that is the black and white image that I was showing earlier. So that needs to be given into the as input to this find contours function in order to give me the boundaries of the area that I want to detect. Okay. The second thing is how do I draw the functions now? How do I draw that particular contour? So that is done using this draw contours function. And the next thing is calculating the centroid and then displaying that. So this is done using this CV2 moments function that I am specifying here. CV2 moments is basically used to calculate a lot of different kind of information about a contour that is getting detected in an image. So I can try to find out the centroid, or I can try to find out other information about. So that is given in the documentation itself. And then finally, once I find the centroid Cx and Cy, then I simply write I annotate that into that image. So using the CV2 put text function that we discussed earlier. Yeah, so there are a couple of questions. First is boundary contour is square shaped. Can we try for other uneven objects? Yes, so it will detect any uneven object. So it's not actually required that it has to be an even square shaped object. If I had a ball or something, I would have shown you. So step 5, I have skipped because we are a bit short on time, and I don't think I would have time to show the other demo as well. So step 5 is basically that is just taking filter out the area, filter out the largest area contour. So there might be smaller contours getting detected in this image as well, that we don't want. We just want the largest boundary of the largest contour here. So for that we specify one particular threshold, that is 200. That is set on based on the kind of a little bit of tweaking that needs a little bit of tweaking. Based on that, we say that yeah, all the contours which have an area greater than 200, I want to show in the draw contours function. Yeah, so as for the code, so yeah, I will be this will be shared with you after the session. So I have there's a GitHub repo that I have created. It has all the code for this session that I'll share with you. Yeah, so Gargi, I think we are out of time, right?
Yeah, we have exceeded a little, and we also.
Yeah, I think I'll just so I don't have the like since we don't have the time to discuss the last final part. I just had to show invisibility cloak. Uh, so I'll just give you a basic demo and uh, I'll just show the basic idea behind this. So I won't go into explaining the code in detail. I'll just show you the demo of how this invisibility cloak thing works actually. So since I think some people might be.
Sure, just let me know when you're getting done, then I'll start the quiz for that.
So just give me 5 minutes. I'll just show the demo of that.
Cool, cool. No problem. Abhinav, we can't hear you. This will be starting a quiz shortly.
Hello?
Yeah, Abhinav. I think we lost you there.
Okay, just a second, please.
Yes. Automatic
Seems to be some noise with this. Yeah, is this visible? Okay, so I won't be going into the code, but I'll just tell you that what exactly happens, what exactly is happening here. Okay, so this is the video that I captured. So this video has like for I think 30 seconds, this it is only showing the background. It is only showing the background. After that, I come into the frame, and this is the green colored cloth that I have. So I showed you object detection using color based filtering. So this is also a similar kind of a thing. What it's doing is that it's detecting particular this particular piece of cloth using the green color based threshold. So what exactly is happening here is that for the first couple of seconds, it just takes this frame it just takes this frame and saves that frame. Okay, so it just takes this frame and saves that. After that, once the video starts moving, it replaces the area where the green is visible. This green is visible, it gets replaced with the background. So that gives the illusion of the invisibility cloak. Okay, so here, if you can see, this is the initial background that gets captured. So this is the initial background that gets captured for the first few seconds. After that, once the video is started, everywhere that green color is detected, this gets replaced with the background. So obviously, this is if the video is a bit clear, this is not perfect because you'll see that there are small issues with the lighting, and that can be solved with some proper image processing. We can adjust the lighting and stuff like that. But yeah, this is the basic idea. So I won't be going into the basics of this code, but this is what happens. First, we are doing the HSV based filtering. After that, we are removing some noise here. Then we are doing that replacing that background thing using the using by creating a mask. And then we are adding okay, so I guess that's all from my side. So if you guys have any lingering doubts, please ask. I'll stop sharing.
If none of you have doubts, I'll just share the quiz in a minute.
I see a couple of people have hands raised. If you have any questions, you can ask on the chat itself.
Just you can clear doubts for a minute. I'm just trying to put the quiz link up.
Gargi, your voice is breaking in between. I'm not able to hear anything.
I just said that you take questions for a couple of minutes and then I will send the quiz link. Can I share the quiz link now? Okay. So everyone, I'm sharing the quiz link. You all will have 10 minutes to complete the quiz and then I will stop accepting responses.
Yeah, so the quiz is launched. So if you guys haven't started the quiz, then please start it. It's the link is posted in the chat.